Why did fat get a bad rap? Like, why is there even confusion about this macronutrient? We have carbohydrates, proteins, and fats. They're essential. We need them. But why do you think it got such a bad rap?
So my guess is there's two reasons it gets a bad rap. One has to do with body mass index or obesity, right? And that fat is something we eat. And so you can do a simple kind of, I eat it, therefore I am it, right? So
Mm,
that I've oversimplified it, but I think people have that. And fat has a lot of calories, right? So a gram of fat has about 9 calories, whereas the protein and the carbs have 4. So it adds up quite quickly. And there's a lot of nuance on this. There's this realization that, certain types of cholesterol in your blood were associated with heart disease, and that certain types of dietary fats were more prone to increase that or more prone to decrease that. And maybe a public health message was, hey, let's not get into this nuance. Fats are bad because of cholesterol, and tried to oversimplify it. So there was kind of, I see two things. One is this caloric association with body fat, and another one with cholesterol. And then there's always some nuance in some other diseases.
got it. So if we were then to go out and help people understand what's the difference between, let's say, what could be considered healthier fats or fats that when we consume them have a chance of improving our overall health and well-being, and other types of fats that when we consume them maybe would typically be associated with maybe a negative or a negative impact on our health and well-being, what might some of those differences be, and how can we tease that apart a little bit?
Yeah, so there are kind of three broad categories of fats, okay? And one we call saturated fats, and it has to do with the position of the hydrogens, and we sometimes say double bonds for simplicity. And those ones are solid at room temperature, so things like butter. Then you get ones like olive oil, which have one double bond in them, and that's something. Olive oil is the classic example, which is a liquid at room temperature, but if you leave it in your fridge and it's not fake, it'll freeze, right, in your fridge. If it doesn't freeze in your fridge, you got a fake olive oil, just so you know.
Good test. All
Cheap
right.
way of testing that. And
Yep.
then we've got these polyunsaturated fats, which have a lot of double bonds and are almost liquid, always liquid, even at cold temperatures. And that's actually how I got into this, because people don't realize this, but your brain is almost as fat as your body fat, okay? Except your brain's got these polyunsaturated fats that we call omega 3s, that are found in fish, and they're doing remarkably important things in your brain and in a variety of your body cells. So there's a little bit of confusion sometimes because we're trying to lump fat as a macronutrient. And I will say, with maybe the rarest exception, you eat too much of it, and it's going to end up on your tummy and your waistline because it's got a lot of calories into it. But so anything in excess has that problem. But without that, there's even some nuance in the different types of fats and the food sources they come from as well.
Interesting. So we have saturated fats, monounsaturated fats, polyunsaturated fats. Can you give us some examples of each of those, perhaps, just to help people understand a little bit more about what those are?
Yeah, saturated fats are, like I said, they're usually solid at room temperature, so think butter. But the samples I showed you a while ago from steak actually is quite rich in saturated fats. Those are some of the major food sources. Palm oil is actually famous for
Hmm.
being a saturated fat source, and so is coconut oil. And if you look at them, if you have a jar of them around, we don't have palms much, but they're solid at room temperature. Now, you got to take everything with a little grain of salt here, because it's predominantly saturated fat.
Mm.
Okay, it's going to have other things in it too, but it's so saturated that it's solid at room temperature. Monounsaturates, the major sources are things like olive oil is actually the famous. The fat's called oleate from olive, the same sounding thing. That's kind of one of the most famous sources. Some other oil sources have it. Canola oil's got a fair amount of oleate. And then the polyunsaturates, we actually have two more branches in there. There's technically a third, but we never talk about the third. Omega 6s and omega 3s. And the omega 6s are famous for being in things like corn oil, sunflower oil. And then in some farm practices, the animals eat corn oil, so the animals get a fair amount of omega 6s in them, like some chickens. So that's where you are, what you eat eats kind of story. And then the omega 3s have two sides to them. There's this plant based omega 3 called alpha linolenic acid, which is a terrible name because the omega 6 is called linoleic acid. So you got linolenic
Jeez.
and linoleic. Keeps people like me employed with these
Yeah.
names. And then you got these longer chain ones, these omega 3s that can only be found, not can only be found, are predominantly found in fish and aren't in plants. And sometimes we call them EPA and DHA.
Mm.
And DHA is the one that accumulates in your brain, makes up almost 15% of the fatty acids in your brain, depending on the circumstances.
That's so cool. So let's get, people are always fascinated by the brain. So let's go into this omega 6 versus omega 3 discussion a little bit further, just to make sure that we're super clear about that. And you taught me that omega 6s have some pro inflammatory effects, maybe not the best impact on our health and well being, yet omega 3s, which sounds similar, actually has a positive impact, especially on the brain, especially in myelin. I would love to just dig into that a little bit further.
Yeah, so there's a little bit of truth in all these things and a little bit of oversimplification for
Yeah.
these. So one of the famous omega-6 fats is called arachidonic acid, and it gets converted to a series of molecules in our body that promote inflammation. And this is famous, Nobel Prize given out in 1982 for this, because that's how aspirin works, by stopping that reaction. So it stops the conversion of arachidonic acid to those molecules. The omega 3s compete with that reaction and have some of their own little like metabolites that seem to stop or block inflammation or resolve it. Now, it's not perfect because there's one of these molecules from arachidonic acid called a lipoxin that's actually famously anti-inflammatory. So we have to be careful with lumping them all one way and the other. And it depends on the tissue, depends on the time, depends on a bunch of these reactions. But in general, we eat a lot of omega 6s in our diets. Most people in North America eat 10 to 15 times more omega 6s than omega 3s. So we don't have any issues with, people not eating enough omega 6s. If you're going to try and balance those reactions out, the way to do it is probably to increase your omega 3s. And some people would argue maybe lower your omega 6s a little bit will get that a little more in classical balance. A little bit of debate on how to best do that, right?
Got it. Is there a difference between omega 3s that we take in from plant sources versus fish sources, for example? Is there anything around
Yes.
that?
Yes. So the plant source it's an 18 carbon omega 3 called alpha linolenic acid. And you take that and you use it for some things, but you send it to your liver, and then you can put 2 carbons on it and put some more double bonds and put 2 more carbons, and it becomes eicosapentaenoic acid. Eco means 20, and DHA is docosahexaenoic acid 22. So you can take that plant one, put it into your liver and have it do that and send it to your brain as you need it, or you can just eat them directly. Now, I've oversimplified that a little bit, and there's a huge debate in our field on how good we are at those steps in our liver. Okay, so I'll simplify it again and say that you can do it in your liver, but you'll never be able to do it as well in your liver as just eating a ton of fish. So you can eat grams of DHA in fish, and you'll never synthesize grams from the alpha linolenic acid. The liver just doesn't have that kind of capacity.
Got it.
Where this gets a little confusing is some people say, oh, we can't make it, or we're really not good at making it. I think we're kind of fine at making it. And then there's a line where things become therapeutic or nutritionally relevant, and we probably can't cross that line in our synthesis abilities.